So as we solve polynomials here, we need to go backwards for a few minutes and start with our most basic of polynomials, which is the quadratic. How do we solve a quadratic? And there's four methods that we've learned either in Algebra 1 or Algebra 2, and we've talked about all of them in Algebra 2. But what's one of them? Teddy? Split the middle, which I'm going to be a little bit more specific because there's more than just split the middle, so we'll say factor. Because there's more techniques than just split the middle. Another method that we use to solve quadratics. Well, how about the quadratic formula? Another one? We did super well with it, and that was complete the square and finally the fourth one, which is the one that I think is the hardest to remember sometimes, is that we solve by graphing. When we're working with polynomials, in this case specifically quadratics, quadratic has a degree of 2, so how many solutions will we get when we solve a quadratic? And again, for those of you who haven't taken the test yet, that's something good to know. Quadratic has 2 answers. Cubic has 3 answers. Quartic has 4 answers. Quintic has 5. But quadratics have 2 answers. So as we take a look here at the first example, we're going to solve these quadratics by factoring. So we look at this one, x squared minus 49, and we're going to turn it into 2 parentheses. Do you remember what the method is? Oscar? We could find the greatest common factor, but I'll ask you again in a couple minutes, more specifically. That's a good technique to use, greatest common factor. It's not greatest common factor. This one is the difference of squares. And when we solve something with the difference of squares, or when we factor with difference of 2 squares, we can take the square root of x squared, which is x and x. We can take the square root of 49, which is 7 and 7. And difference between 2 squares, different signs. But what we're doing today is we're not only factoring, but we're also solving. And in order to solve, we're going to take our factors. X minus 7, we're going to set it equal to 0. X plus 7, we're going to set it equal to 0. So we're going to add 7 to both sides. And we get x equals 7. We're going to subtract 7 from both sides. So we get x equals negative 7. Again, it was a quadratic. If the quadratic has 2 solutions on our blank there, x equals 7. X equals negative 7. And what we did with polynomials is we split polynomials up into 2. So in the last unit, what we did is we focused more specifically on the graphs. Now what we're focusing it on is the equation to come up with the roots. And oftentimes we were able just to look at the picture and identify the roots. But as I flip over here to this next problem, we did the difference of 2 squares, but then Oscar's going to tell us that we're going to use Please come factor on this one. And we should always look and see, can we factor GCF first? And what we see between 8 and 24 is it's 8. Between n squared and n, it's n. That's our GCF. We're going to factor that out. Well, 8n squared divided by 8n is n. We had 2 n's, we took 1 out. 24n divided by 8n is 3. And once we get that, we're going to set each factor equal to 0. Because we want to solve now. It's 8n equals 0. And n plus 3 equals 0. So when we divide both sides by 8, we get n equals 0. When we subtract 3 from both sides, we get n equals negative 3. So once again, because this is a quadratic, our highest degree is 2, we will have 2 solutions. And those solutions are n equals 0 and n equals negative 3. Our degree of our polynomial determines how many roots we will get. So if our highest power was 10, then we would get 10 answers. If our highest power was 100, we'd get 100 roots. But luckily for us right now, we only have 2 solutions. As we get to our next problem, which is still to solve by factoring, and it probably is the most common of factoring, which is the split the middle technique. And when we split the middle, the 4 is the A and the 3 is the C. 4 times 3 is 12. A times C. And our factors of 12 are 1 times 12, 2 times 6, and 3 times 4. Will any of those factors either add or subtract? And actually what I usually say, will any of those factors combine to be 1, either adding or subtracting? Matthew? The 3 and the 4. And in fact, what it's going to have to be is it's going to have to be 3 minus 4 will give us negative 1. And when we split the middle, we're going to write down our 4x squared, which we started with, and our minus 3. And conceivably, what's going to be easiest for you is to write minus 4x plus 3x. And then we can group. There's our GCF again. So in our first group, our GCF is 4x. And then we're left with x minus 1. 4x squared divided by 4x is x. 4x divided by 4x is 1, and yes, we have to write the 1. Over here in our second group, we factor out a 3. And when we factor that out, 3x divided by 3 is x. Negative 3 divided by positive 3 is negative 1. Which is going to work out well for us because what we're looking at here is in each group, we have an x minus 1. And then our single values that are left are going to form the second binomial in this factoring of 4x plus 3. But what we're trying to do on these problems is we are trying to solve the quadratic. So we're going to take x minus 1 and we're going to set it equal to 0. We're going to take 4x plus 3 and we're going to set it equal to 0. So we're going to add 1 to both sides, we get x equals 1. We're going to subtract 3 from both sides, we get 4x equals negative 3, and divide both sides by 4. So x is going to equal negative 3/4. Once again, what we said. We said that this is quadratic. Quadratic, we get 2 solutions. And they are x equals 1 and x equals negative 3/4. The exponent determines how many solutions we will get. The highest exponent, I might add. But in our last unit, we worked with quadratics, we worked with cubics, we worked with quartics, we worked with quintics. So there's the quadratics. Now we're going to switch over to cubics. And how do we use these techniques to solve the higher order polynomials? Well, for cubics. For all cubic polynomials, and we do well on this. The degree in this case is 3. That's what a cubic is, to the 3rd power. So how many solutions are we going to get? 3. And once again, we can look and see. Split the middle might be a possibility. Using the greatest common factor, that might be a possibility. We might have to factor a cube. But as we start here, I don't want to jump right into factoring a cube. I want to start with greatest common factor. And the greatest common factor on this problem is x. We factored out. Goes up with x squared. We had 3 x's, we took out 1, so we have 2. 3x squared divided by x is 3x. And 4x divided by x is 4. Now, when we did this earlier in the year, we split the middle on this. I just want to suggest to you that your teacher next year might not split the middle on this one. He or she might do this. X squared is x times x. And then if we look at the 4. 4 is 1 times 4 and 2 times 2. Will either one of those factors combine to be 3? Hit me. 1 and 4. 4 is negative. Now, some of you are looking at me funny. Here's how I'm going to erase this. Then not much is going to change. So if you wrote in pen, it'll be okay. You can fix it in a minute. But if we do split the middle, here's A, here's C. 1 times 4 is 4. So we still have an x there. But if we split the middle, 1 times 4 is 4. This process is still the same. The nice part on this one is that there was no number in front of the x squared. But to split the middle, because I could see I was confusing, I don't want to be confusing. And then we can say plus 1x minus 4x. And then we can group. I did separate out the GCF, which is still going to help us get one of our 3 solutions. But here's our 2 groups. And in the first group, our GCF is x. We had 2 x's, we took out 1, so we're left with 1. X squared divided by x. 1x divided by x is 1. Be careful here in our second group, because it's minus 4x, but our GCF is negative 4. And when we factor that out, what's going to happen is negative 4x divided by negative 4 is x. And for second term, negative 4 divided by negative 4 is positive 1. And in general, whatever we get in the first parentheses, we will get in the second parentheses. And then what we see in our group there is we've got x plus 1. X plus 1 is in each group. I don't think I said that very well. And then our singles, x minus 4. And lastly, don't forget the original GCF. And what we're looking for here, we're solving a cubic now instead of a quadratic. So when we solve a cubic, we should end up with 3 solutions because our highest degree is 3. And our solutions are going to come from x equals 0 and x plus 1 equals 0 and x minus 4 equals 0. I'm not going to skip steps, but if you can tell me that x equals 0 and x equals negative 1 and x equals positive 4 without doing those steps, I'm fine with that. But where did I get those answers from? Well, the 0 to get x equals negative 1 is subtracted 1 from both sides. So we get x equals negative 1. Add 4 to both sides. And we get x equals 4. There's our 3 solutions. So as we take a look here at letter B, again, we're still using the techniques of solve by factoring. So this one here, we haven't specifically seen this technique, but this problem is a factor by grouping problem. We didn't have to split the middle and then do grouping. We're just going to do grouping. And remember, when we group, we can make a group with the first 2 terms. And we can make a group with the second 2 terms. And ultimately what we're trying to do is we're trying to solve this cubic. So in our first group, our GCF is x squared. Smallest exponent between x cubed and x squared. We had 3 x's. We took 2 of them out, so we just have 1 left. We had 2 x's. We took them both out, so minus 5. In our second group, 3x minus 15, our GCF is 3. And when we factor that out, 3x divided by 3 is x. Negative 15 divided by 3 is negative 5. And now, we have x minus 5 in each group. We also have our single x squared and 3. And now we're going to take each factor and set it equal to 0. We cannot do anything else with x squared plus 3. We can solve. That's all we can do is solve it. So we're going to take x minus 5 and set it equal to 0. We're going to take x squared plus 3 and set it equal to 0. And then we're going to add 5 to both sides. So x equals 5. But it's probably the second one that maybe is a little bit more concerning to you. I think it'll be straightforward. When we start by subtracting 3 from both sides, we want to isolate the x squared term, which ultimately is what we're trying to solve for. We get x squared equals negative 3. And in order to solve this, we need to undo the square. The inverse operation of squaring is square rooting. And if we square root x squared, then we need to square root negative 3. Well, we get x. Square rooting and squaring again cancel each other out. Over here, we're going to simplify. And 3 is the square root of negative 1 times the square root of 3. Sorry, negative 3 is the square root of negative 1 times the square root of 3. Well, what's the square root of -1? I. So this is going to be x equals I. Can we take the square root of 3? No, it's irrational. One other thing that we need to notice. Positive times positive is positive. Negative times negative is also positive. This is plus or minus. And that's something that sometimes people forget. And if you can remember that a cubic has 3 solutions, here's what they are. X equals 5, the value we found a couple minutes ago. It's x equals positive I radical 3, and x equals negative I radical 3. By the way, I am fine with you writing plus or minus I radical 3. I have no issue with that. But what you need to realize is that plus or minus I radical 3 represents 2 solutions to the problem, and a cubic has 3. So for the video purposes, check with your Algebra 2 teacher and see if they want you to write plus or minus, or if they want you to write all 3 of the values out. For me, I am fine with you writing plus or minus I radical 3. So as we flip over here to the next cubic, as we look at this, again, some of our techniques that we've used today, we've used difference of 2 squares, we've used GCF, we've used split the middle, we've used grouping. Do you have any thoughts on how we can start this problem? Well, I'd call on Oscar again, because he's told us once today. GCF. This one's a GCF. And so the first thing that I notice when I see this is it's x cubed and it's x squared and it's x. So we've got a GCF of x. Do we have any GCF of numbers? Tiffany? 2. 2x cubed. 2 and 10 and 12, they're all even numbers. So not only is x a GCF, but 2 is a GCF. And when we factor that out, 2x cubed divided by 2x is x squared. We had 3 x's, we took out 1. 10x squared divided by 2x is 5x. 12x divided by 2x is 6. And now let's split the middle. So 2x, and then actually I'm going to use a bracket here. X squared and 6, but remember, our A times our C. Where I'm getting that value, A times C. 1 times 6 is 6. And the factors of 6 are 1 times 6, 2 times 3. Will either of those combine to be 5, either adding or subtracting? Tiffany? -1 plus 6. What happens when we multiply -1 times 6? Oh, we'll get -6, and is that going to work for us? Nope. So let's try +2 and +3. So we need to be a little bit careful with that. So we just put in our signs. +2 times +3 will give us a +6, which is, again, something that we need. So when we fill this back in, plus 2x plus 3x, we've split the middle. And now we're going to group. What's in common in our first group is an x. Again, we take out the smallest exponent between x squared and x. We had 2 x's, we took 1 out. We had 1x, we took it out. So we're left with x plus 2 in our parentheses. Over here in our next group, the GCF between 3x and 6 is 3. 3x divided by 3 is x. 6 divided by 3 is 2. Again, we're solving a cubic. We're looking for 3 roots on this problem. And what we see is that we have an x plus 2 in the first group and x plus 2 in our second group. So we have 2x times x plus 2, and then our single here is x plus 3. A cubic polynomial is going to have 3 solutions. Again, the reason is the highest degree in the problem determines how many solutions we have. They can be real, they can be imaginary, but what we're going to get, or where they're going to come from, is we're going to set 2x equal to 0. We're going to set x plus 2 equal to 0. And we're going to set x plus 3 equal to 0. And then we're going to divide everything by 2 in this particular case. So we get x equals 0. There's one of our roots. I hope that you can tell me that x equals 0 and x equals -2 and x equals -3 without doing those steps. But again, I'm not going to overlook the work to get there if you don't know where it came from. We're subtracting 2 from both sides. And we get x equals -2. And we're subtracting 3 from both sides. We get x equals -3. Again, 3 solutions is what we are looking for. And those solutions are x equals 0, x equals -2, and x equals -3. So finally here, before we take a break, cubics. Some of you, when I said cubic, probably cringed a little bit, because with cubics, we can factor a cube, but we need to remember how to factor a cube, which is what example D is. When we factor a cube, what we're going to do is we're going to turn this polynomial, this binomial, into a binomial and trinomial. And it depends on your Algebra 2 teacher, but I taught the method SOAP. So hopefully at least it sounds familiar to you. And what SOAP stands for is it stands for same sign, opposite sign, always positive. Eventually what we're going to have to do is we're going to have to use the quadratic formula on here, but before we get there, we need to get this factor. So our first step that we have to do is we have to find the cubed root of 8x cubed. And I think it's already on my calculator, but if we look here, the cubed root, I want to show you how to do it. Math, number 4, and 8. The cubed root of 8 is 2. But we're also going to have to find the cubed root of 27, if you don't know it already. And again, we're going to go to math, number 4, and 27. And that's going to give us 3. So we're taking the cubed root of both these values. So this is going to be 2x, cubed root of x cubed. 27, the cubed root of 27 is 3. And in that parentheses, we're going to have the same sign as what's in the problem. It's a plus. Same sign. 8x cubed plus 27, 2x plus 3. Same sign, which means that our other two signs. The next sign is going to be the opposite of positive, which is negative. And AP stands for always positive. So there's those signs. To finish the factoring cube, what we're going to do is we're going to ask ourselves, well, what is 8x cubed divided by 2x? 8 divided by 2 is 4. X cubed divided by x is x squared. We had 3 x's, we took out 1, we still have 2. Divide 27 by 3. 27 divided by 3 is 9. And the middle value, we already have all our signs in there, so we don't have to worry about that, is determined by taking 2x times 3, and 2x times 3 is 6x. That's the factoring cube method. And now what we're going to do is we're going to set each of these factors. 2x plus 3 equal to 0. And we're going to take 4x squared minus 6x plus 9 equals 0. And hopefully I left enough space. But as we subtract 3 from both sides, we get 2x equals negative 3. Divide both sides by 2, and we get x equals negative 3 halves. We eventually are going to be looking for 3 solutions, and there's one of them. But over here, here's our A and here's our C. 4 times 9 is 36. And the factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Will any of those factors combine to be 6, either adding or subtracting? No. We cannot factor 4x squared minus 6x plus 9. Consequently, we are going to have to use quadratic formula, which you can see on your paper, even though I can't see mine right now. So we're going to fill in quadratic formula. Negative b plus or minus the square root of b squared. And if you're going to type that negative 6 squared in your calculator, you need to have parentheses. Negative b squared, negative 6 squared, minus 4 times a times c, all divided by 2 times a. Well, we simplify a little bit more. Negative and a negative gives us a positive 6. Negative 6 squared, again, if you're typing that in a calculator, you must have parentheses, is 36. 4 times 4 times 9 is 144. All divided by 2 times 4, which is 8. So now, we simplify a little bit more. We get 6 plus or minus the square root of negative 108. 36 minus 144 divided by 8. And we're going to have to break this down. Square root of negative 1, square root of 108. So we know that the square root of negative 1 equals I, but 108. Might have to do a little bit more work with. 2 times 54, there's other factors. 54 is 9 times 6. 9 is 3 times 3, and 6 is 3 times 2. So all of those factors together are going to be 2 times 2 times 3 times 3 times 3. Notice that I grouped the 2's together and the 3's together. We already know square root of negative 1 is I, so we have that out there. But when we're simplifying the square root, we need 2 of the same to take out 1. 2 of the same value to take out 1. So what we have is we have I times 2 times 3, square root of 3. So really sorry, because you're probably running out of space now on your paper. But when we put this back in here, this is going to be 6 plus or minus. 2 times 3i is 6i. Square root of 3. That's what the square root of negative 108 equals. It equals 6i radical 3. divided by 8. And unfortunately, there's one more step even now. What we have to notice is that 6 and 6 and 8 all have something in common, which is that they're all even. So when we get to the point where we're going to get our 3 solutions for our cubic, the first one is going to be from x equals -3/2. But our next two values are going to come from our quadratic formula here. And again, I kind of got ahead of myself, but 6 divided by 2 is 3. 6i divided by 2 is 3i. And 8 divided by 2 is 4. I am fine if you write on your solution line 3 plus or minus 3i radical 3 over 4. But since we said 3 solutions, what are they? There's the first one. The next one then is 3 plus 3i radical 3 over 4. And our third is 3 minus 3i radical 3 over 4. Cubics have 3 solutions. So now we're going to talk about quartics. We've done quadratics, we've done cubics. Let's do quartics. And quartic has a degree of what? Do you remember? And at least you should hopefully be thinking 4. And consequently, because it's to the 4th degree, we should have 4 solutions. And sometimes we might have to use the quadratic formula again. But as we look at this problem, our initial thought, I hope, is that we need to group. This is a grouping problem. And when we group it, we're going to group the first 2 terms together, and we're going to group the last 2 terms together. And then we're going to look for GCFs. So the GCF between x to the 4th and 3x cubed is x cubed. And then we're left with x to the 4th by x cubed. We had 4 x's, we took out 3 of them, so we have 1. We had 3 x's, we took them all out, we have plus 3. Over here in the next group, believe it or not, 27 goes into 81 evenly. So it's going to be 27x plus 3. And then what I hope see is that in each group, we have an x plus 3. So we've got x plus 3 times x cubed plus 27. But as we look really closely here, x cubed plus 27 can factor as well. It is a cube. And so we talked about SOAP a little while ago. But once again, SOAP stands for same sign for the S, O, opposite sign, AP, always positive. And what we do is we take the cubed root of x cubed, and we get x. We take the cubed root of 27, and again, it might still be on your calculator screen as well. The cubed root of 27 is 3. Remember that the cubed root button is math, number 4. So when we take the cubed root of 27, it's 3. And then we're going to have our same sign. So it's x cubed plus 27. It's going to be x plus 3. Since it's same sign, our next sign in our polynomial is going to be a minus. Opposite sign. And our last sign is always positive. And now we can finish factoring. X cubed divided by x is x squared. 27 divided by 3 is 9. And the middle term is x times 3 equals 3x. So we're in a good place here, but this is still a little bit of a lengthy problem. But we can figure out x plus 3 equals 0 by subtracting 3 from both sides. We get x equals -3. And we can do the same thing with the next parentheses. And in fact, we get the same value in there, so our -3 has a multiplicity of 2 if we talk about the last unit. But eventually what's going to happen here is that we're going to get down to the bottom here. And a quartic has 4 solutions. So we just found 2 of them. X equals -3, x equals -3. So we have to find the other 2. And the other 2 are going to come from the x squared minus 3x plus 9. And if you think about it, the factors of 9 are 1 times 9 and 3 times 3. Will either one of those factors ever combine to be 3? And no. And what that means for us is that we need to use the quadratic formula, which you should be able to see on your paper there. Again, if you go into the space of part B, it's okay. That problem will be shorter. But it's going to be -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. If you're typing this in the calculator, you have to have parentheses around that -3 for the b squared part. Double negative gives us positive. -3 squared is 9. You need parentheses to type it in your calculator. 4 times 1 times 9 is 36. All divided by 2. 2 times 1. Well, we get 3 plus or minus 9 minus 36 is -27 over 2. And now we need to simplify the square root of -27. Which is going to be the square root of -1 times square root of 27. What does the square root of -1 equal? I. That equals I. 27, some of you might even have it memorized because we seem to use that value a lot. But when we're taking the square root, what we're looking for is we're looking for 2 of the same value. Take a 1. And we get 3 radical 3. But as I scoop this stuff down so that it's not in the way anymore, come on, oh good. What that equals then is that equals 3 plus or minus 3i radical 3. Don't forget that we took the square root of -27. Divided by 2. And again, I am fine if you write 3 plus or minus 3i radical 3 divided by 2. But if we want to get technical, we said it was 4 roots. It's 3 plus 3i radical 3 divided by 2. And it's x equals 3 minus 3i radical 3 over 2 for our 4 solutions. You may write the answer as 3 plus or minus 3i radical 3 over 2. But to some people, 4 solution means show me all 4, which is what I like to do. as we switch over here to our last two examples, y to the fourth minus 16. Well, sometimes people look at this and they go, oh, I don't know what to do on this. But if we go back to the very beginning of what we started with, our first example was the difference of squares. And this one is still the difference of squares. And maybe we need the quadratic formula, and maybe we don't. But don't get confused by the y to the fourth. We can start just like we did on 1a. Y to the fourth, we can break it apart. We can take the square root. Y to the fourth is y squared times y squared. And 16 is 4 times 4. Difference between two squares, different signs. Well, if we're really going to factor completely here, we can still factor a little bit more. And it happens to be our first parentheses, which is the y squared minus 4. That is the difference of two squares again. Y times y. 4 is 2 times 2. Different signs. We cannot factor the other parentheses of y squared plus 4 because there's a plus in it. There's a plus in that problem. But we're to a point where we can actually get our solutions. In fact, this is a quartic, so remember, we're looking for 4 solutions because it's a quartic. And I hope that at least on 2 of them, you don't have to show this work. But y minus 2 equals 0, add 2 to both sides. And there's nothing wrong if you have to show the work. Just trying to save you a little bit of work. So we get y equals 2. We've got y plus 2 equals 0. So we can subtract 2 from both sides. And we get y equals negative 2. And then we've got y squared plus 4. So y squared plus 4 equals 0. And in order to solve this one, and we can solve it, we're going to subtract 4 from both sides. And we get y squared equals negative 4. We're going to take the square root of both sides. That's how we solve that squared problem. We're going to take the square root of both sides. Square rooting and squaring are inverse operations. They cancel each other out. So this becomes y. And over here, we're going to take the square root of negative 1. We're going to take the square root of 4. What's the square root of negative 1? What's the square root of 4? 2. Don't forget, that's going to be plus or minus 2i. That squared tells us that we're going to have 2 solutions. We're looking for a total of 4. Our other 2 are y equals 2i and y equals negative 2i. Y equals 2, y equals negative 2, y equals positive 2i, y equals negative 2i. 4 solutions. So to finish, this problem, 4x to the fourth minus 13x squared plus 9, sometimes confuses people because it's got 4x to the fourth. This is still a split the middle problem. And we may or may not need to use the quadratic formula. But when we split the middle, here's our A and there's our C. 4 times 9 is 36. And we look at the factors. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6, will any one of those factors combine to be 13? And the answer is, it looks like 4 and 9. And in fact, what we have to do is we have to do -4 and -9. So when we split the middle, we're going to write down 4x to the 4th. We're going to write down the 9. And then it's -4, but it's minus, instead of 4x, it's going to be -4x squared, because our middle term is 13x squared. And it's going to be -9, but it's going to be x squared, because our middle term is x squared. And that's what's confusing people. Don't forget the squared on that term. And then we've got the +9. So we're going to factor. Here's a group and here's a group. And our GCF in our first group is 4x squared now. And 4x to the 4th divided by 4x squared is x squared. Then 4x squared divided by 4x squared is 1. And yeah, we must write the 1. Over here, the GCF is 9. And when we factored out that 9, it's actually -9x squared divided by -9 is positive x squared. And +9 divided by -9 is -1. Again, in general, what we get in the first parentheses, we better get in the second parentheses. And we've got x squared minus 1, x squared minus 1. So we have x squared minus 1 times 4x squared minus 9. And we actually can keep factoring. And with the x squared minus 1, you might be able to get both roots from that one, but I think that you'll struggle with the 4x squared minus 9, which is why I highly recommend that we go back to our difference between two squares again. And we can use the difference between two squares on the x squared minus 1, and we can use the difference between two squares on the 4x squared minus 9. X squared minus 1, x squared is x and x. 1 is 1 times 1, different signs. 4x squared minus 9, 4 is 2 times 2. X squared is x and x. 9 is 3 times 3. Difference between two squares, different signs. We are looking for 4 solutions. It's a quartic. If we had x to the 5th, we'd be looking for 5 solutions. If it were x to the 10th, we'd be looking for 10. But as we finish here, some of you are going to be able to tell me that x equals 1 and x equals -1. Otherwise, we're going to do x minus 1 equals 0, and we're going to add 1 to both sides. So we get x equals 1. Do the same thing with x plus 1. X plus 1 equals 0. Subtract 1 from both sides. We get x equals -1. 2x minus 3 equals 0. Add 3 to both sides. We get 2x equals 3. Divide both sides by 2. So x equals 3/2. And you might then recognize that the only difference in this last parentheses is it's 2x plus 3, so it should be x equals -3/2. But just in case you want the work here, as I'm running out of space myself, but if I skip that over, subtract 3 from both sides. We get 2x equals negative 3. Divide both sides by 2. So our fourth and final solution here is that x equals negative 3 halves.